Over the past few months, everyone has been talking about large language models, LLMs, and how they can be used to improve products and life in general. OpenAI, with ChatGPT, has shifted our perspective on models from "oh, it's too complicated" to "how can we apply this to our situation?" Businesses and professionals are inventing more and more interesting use scenarios every day to improve our lives, increasing productivity, reducing costs. ChatGPT is trained on a vast part of the internet and can answer almost any question, from coding to complex science. I believe the first question that comes to any professional's mind when they see such a convenient system is, how can we do the same thing in our product/life? How can we make it so that the capabilities of ChatGPT use not just the entire internet, but also your knowledge accumulated over many years? For instance, all the documentation about your product, or an entire book/lengthy article that you want to learn. The first thing that comes to mind when you have such a need is to load everything into the context. And this is partly a good solution. The GPT model will be able to respond according to your context and will do it very well, but the context window won't allow you to do this. The context window is the amount of information the model takes in and its response to you. The sum of received and created information is the context that the model can operate with. Unfortunately, the context window of the model is only 4,000 tokens, speaking about ChatGPT, or, if you have access to GPT-4, it's 8,000 tokens. But even if you take the latest GPT 3.5 a turbo model with 16,000 tokens, it is still not enough to load, for example, an entire book or an entire section of your website, right? So, what to do in this case? Where to find a solution that will allow us to overcome this limit? Vectors come to our aid. Details, I'll start discussing this with a specific example. Imagine that you have 100 documents containing information of 100,000 tokens, 70 to 80,000 characters. And you want the model to be able to use this information to answer questions. To do this, the first thing we need to do is cut all these documents into pieces, say, 2,000 characters each. In our case, we got 40 pieces, which we need to transform into vectors. You probably have a lot of questions right away, but I promise that once I finish, everything will become clear to you. After we've turned the 40 pieces into vectors, we can start working with them and use them to answer questions. Each time a user asks a question to our system, we will transform his question into a vector as well, and then, using cosine distance, find the vectors of our document pieces closest to the question vector. It will search for the most suitable vectors where information on the topic is likely to be contained. And then, the last step, we use the vectors of these pieces, we transform them from a vector into text. Then, we add them to the GPT context and ask the question that the user asked again. And GPT responds. In other words, vector search is essentially a tool that allows you to add only relevant information from all the data you have loaded to the model's context. It's probably not so easy to understand if you've never worked with vector bases and have no mathematical background. I will attach a conceptual diagram of how this works here to make it clearer.